Solving an exponential equation is an equation where what you want to solve for is in the exponent. So this is the most basic one, 2 to the x equals 3. And there's some different ways that these can be solved, but we're going to use the same technique every time. Well, in fact, we're going to use one of two techniques. You've already solved some exponential equations. In fact, the quiz that we just got back had a bunch of exponential equations you had to solve for. They were all non-calculator, and all of them happened to be in, you could change the bases because something happened in the same column of your powers chart. But there are times like 2 and 3, you can't change the base to make those bases the same. In which case, this will be a calculator question. And the way that you're always going to solve an exponential equation is by taking the log of both sides, using your skills as at expanding your logs in order to get that x out of the exponent. Because our third log law up there says log a of m to the n is equal to n log am. In other words, you can bring an exponent out in front under certain circumstances. So when you take the log of both sides, and it doesn't matter which base you use, so people normally choose a common log, so you don't have to write the base, or the natural log. And it doesn't matter which one you use. So if I go and take the log of both sides, I now can use my log law that says when you have an exponent inside, that exponent can come out in front. And then we can get x by itself and say x is equal to log 3 divided by log 2. Usually they ask for 3 decimal places, so if we go to our calculator and we can type this in, log of 3 divided by log of 2, and we get 1.585. Now, the nice thing about solving all of these equations is you will know at the end if you're right or not. Because it's a calculator question, you can then go back to your calculator. You can use that answer. I like to store it as x. And I can check, what was my original equation? 2 to the x equals 3. So I can check, is 2 to the x equal to 3? And it is, so I know that my answer is right, which is really nice in this unit. You can always do a check to see if your answer is right. In fact, on the exercises I gave you, I didn't give you any answers because I wanted you to practice this. I want you to plug things in to check. So our second example from there was this one. Again, x is in the exponent. Doing a quick look, we can't get the bases the same. So if you can't get the bases the same, you're going to take the log of both sides. Oops. There we go. Now you're going to be tempted here to bring the x out in front. Okay? The only time you can use this log law is when it looks like this. In other words, notice here that that exponent n is to the entire thing inside the log. Whereas in our situation, can you see that your x, the exponent x, is only an exponent to the 3? It's not an exponent to the 2. In fact, you are not allowed to go 2 times 3 and write that as 6. Because your order of operations says you need to deal with exponents before you multiply. And if I did 2 times 3 and wrote 6, I would be multiplying before I dealt with that exponent. So as far as our expanding rules go, we know that if you have log of something times something, that's the same as adding. And at this point, now that that exponent x is to the entire thing inside of this log, so we can now bring that x out in front. So the main thing that logs do is they allow you to pull exponents out from the exponent part in front of an equation. And at this point, we want to get x by itself. you can imagine that each of these are numbers. Well, you don't have, they are numbers. But if you think of that, this is really an easy question disguised to look hard. If I gave you 3 plus 5x equals 2, you'd be able to solve that super easy. This is the same, just with funny looking numbers. Log 2 is a number, log 5 is a number, and log 3 is a number. So if I want to get x by itself, can you see that I would need to subtract this log 2 on both sides? And then, if I want to get x by itself, right now it's x times log 3, I'm going to need to divide everything by log 3. Now we can put this into our calculator. This is where, if you have the fraction button, use it. Because anytime you have more than one thing in the numerator or more than one thing in the denominator, if you don't use the fraction button, you have to add a bunch of extra brackets. Extra brackets on top whenever you have more than one expression, extra brackets on the bottom. So the fact that I don't have to do that, log 5 minus log 2 is really nice, divided by log 3. Again, once you get your answer, I'm going to store that as x. There's 3 decimal places. I'm going to store that as x, and I can check, does it work? Right? My original question was 2 times 3 to the x. So I'm going to try that. 2 times 3 to the power of x. Is it equal to 5? If it is, then we know we've got our question right. If it's not, it means we have to go back and see where we made a mistake. Or sometimes the best method is just to take a break, start your question again, and just be more careful while you're doing it. Sometimes it's quicker to redo a question, especially when you're dealing with a lot of logs, than to try to find your mistake. I can scroll down. So again, all of these are on your page that we've done already. And our last example, solve for x. Now we have x's on both sides. So again, I can't get the bases the same, so I'm going to take the log of both sides. The exponent of x minus 1 is to the whole thing, so I can bring it out in front. And when you bring it out in front, because it's more than one thing, you'd have to put it in brackets. So x minus 1 log 5 equals, and here I can bring the 2x plus 3 out in front, log 3. Log 5 is a number. Log 3 is a number. What can you do when you have a number outside of brackets? You can distribute. And we're going to talk about this because it's going to come up later. You can't distribute a function, but you can distribute a number. Where have we seen this already? Some of you sure like to try to do this. Write this as equal to sine of pi over 3 plus sine of pi over 4. Sine, though, isn't a number. It's a function. This is not allowed. What did you have to do in this one? You had to use your alpha and beta formulas, right? And you had to write the big 4 thing out. So one of the hardest things to start to recognize is when is something a number and when is something just a function. In this case, log of 5 is a number. You could type log 5 in your calculator, push enter, and it will give you a decimal, 0 point something. Log 3 is a number. So because they're numbers, you can distribute them. Distributing them would give you x log 5 minus log 5 equals 2x log 3 plus 3 log 3. And again, if the numbers were neater, this would be super easy for you. But because the numbers aren't pretty, it gets a little bit tricky. what we're going to do, we want to solve for x. So we're going to get all of our values with x on one side of the equation, all of our values without x's, all of our numbers on the other side of the equation. So I would have x log 5 minus 2x log 3, moving that 2x log 3 to the left-hand side. And if I put all the ones without x's on the right, I have 3 log 3, and now I have to add log 5. Now normally, when you had nice numbers, what you would do here is if you had 2x plus 3x is you would combine like terms and write 5x. These are just a little bit not so nice to work with. So here you could just add and get 5, but another way of doing the same thing is saying if there's an x in common in both of those, I can factor it out. You could factor it out here too, just nobody ever does that. Oh, 2 plus 3, that's 5. But you could. So what we're going to do here is we're going to factor out that x, leaving you with a log of 5 minus 2 log 3. That's what's left after I take the x out. It's still equal to 3 log 3 plus log 5. You end up having to write a lot in these questions. That's why some people like to use the natural log instead of the log. It saves you one letter. Everything's the same, but instead of writing log every time, you write ln. One letter less. By the end of the question, it saves you like 28 letters or something crazy. A little bit of time saving. So now, since this is a big number, we can get x by itself by dividing. And we get this large expression which again, if you can use your fraction button, please do. Otherwise, you'd need brackets on the top and the bottom. 3 log 3 plus log 5 divided by log 5 minus 2 log 3. And we get negative 8.345. A quick check to see if we're right. I'm going to store that as x. Go back and look at my original equation. On the left-hand side, I had 5 to the x minus 1. So I'll write 5 to the power x minus 1. Again, since I have the newer calculator, I don't need to put brackets around that. If you have the older version, you would need to put the x minus 1 in brackets. Push enter. Okay, that's what the left-hand side equals. My right-hand side of my equation was 3 to the 2x plus 3. So I'll type that in, 3 to the power 2x plus 3. If they're the same, whew, it's always that scary part. Could have just taught the whole question wrong. They are the same, so we know we've got it right. And so this is solving exponential equations. We can now go to we're actually going to do example number 3 first. So starting with example 3. So here's example 3. I'm going to hand out scrap paper because you've seen some now. Now you need to practice these. So there's 3 questions. Take 3 pieces of scrap paper each. And then we'll go over the solutions shortly. So the first one is very nice, very straightforward. You could take the log of both sides and now use your log law to bring that x out in front. Type that into our calculator, log 12 divided by log 4. Whoops, I forgot a bracket. Log 12, now I forgot a 2. A 2 is not being very nice. There we go. Log 12 divided by log 4. And we get 1.792. I can store that as x. And I can pretend to store that as x. And I can check, is 4 to the power x equal to 12? It is. Notice it came up as 11.9999 because I didn't store it initially. So what happened is I recopied this answer, which is only 8 decimal places. Your calculator, when it first gets an answer, actually has more decimal places stored than you can see. Depending on the power of the calculator, it stores more and more decimal places. When I copied it, it wasn't quite right. But when I plugged it in, I'm pretty certain that that's fairly close. That's fairly close to 12. So I know that that answer will be right. For part B, part B is a little bit more complicated. I'm going to do part B in the normal, more complicated way, and then I'm going to show you a shortcut that I see for this one. Okay? In the normal way, you would say, I'm solving for x in an exponent, and right now, my base is 2. I can't get my bases the same, so I'm going to take the log of both sides. This is how almost all of you started this one, correct? Yes? And then here, because this x plus 1 is just to the 2, you first have to expand using your multiplication rule. And now you can bring the x plus 1 out in front. And because it's more than one thing, make sure that you put it in brackets when it comes down in front. A log of 2 is a number, so I can distribute that and now when solving, I'm going to put all my things on one side that don't have x's, so I'd have log 36 minus log 3 minus log 2, that's equal to x log 2. And finally, divide both sides by log 2 to get x by itself. So we can check, did we make any mistakes along the way? I'm going to use my fraction button here. Log 36 minus log 3 minus log 2 divided by log 2. I've got x is approximately 2.855. 2.585, I think I said it wrong. 2.585. I'm going to store that as x and check if that was the right answer. So if I go back to the original equation, which had 36 on the left and 3 times 2 to the x plus 1 on the right, are they the same? Yes, it's equal to 36. So we know we've got it right. All right. Are you okay? Oh.
I divided the 36.
Nice. That's what I was going to say as a way to make this one a little bit shorter. So I'm going to erase this. What you do to equation on one side, you do to the other side. You can use all of your math rules up till now. Nothing's changed. And what Riley said, what happens if we divide both sides by 3? Then I'm going to get 12 equals 2 to the x plus 1. This makes our equation more simple because we don't have that extra multiplication. And now if you decided to take the log of both sides at this point, log of 12 equals, and that x plus 1 could come out in front, log of 2 You could do the same distribution that we did last time. Move the log 2 over. Log 12 minus log 2 divided by log 2. Just a quick check, does that come out to the same thing? Log 12 minus log 2 divided by log 2. 2.585. Perfect. Same answer as before. So sometimes if you can simplify your equation earlier, then it can make your life even easier. Right? If you want, you can play around with these logs even further. Right? 2 to the x plus 1. Sorry, I just feel like playing. So 2 to the x plus 1, would you agree that that's the same as 2 times 2 to the x? 2 to the 1 times 2 to the x. Because what's the exponent law? You add exponents when you multiply bases that are the same. So I could continue even further and divide both sides by 2. Right? And then you could take the log of both sides. Or if you wanted to play around even further, you could just change it to log form if you got that form on your calculator. The exponent is x, the base is 2, the answer is 6. And if I type that into my calculator, log base 2 of 6, I also get the same answer. Pretty cool. So, yes, this is what I want you to be able to do. Take the log of both sides and solve for it. That's the main skill that we're working on. Okay? Are there ways to do things shorter? Yes. But they're not always, they don't always work in all situations. And so we want to really develop our skills in expanding. But if you want to play around with things, there's ways to play around with them. Our third example. And for the last two, just to keep things fair, I'm going to use the natural log instead of the log. It just sounds scarier. It's not scarier. It's exactly the same rules. You see x in the exponent. So you take the log of both sides. But this time I'm going to write natural log instead of log. You still can bring the exponents out in front. You can still distribute. When you've got x's on two sides of your equation, bring all your x's to one side of your equation. Put all your numbers on the other side of the equation. So that you can factor out your x. And you can type that into your calculator. Negative natural log of 3 divided by natural log of 3 minus natural log of 6. 1.585. And again, we can store that as x. And this is where the store button really becomes important, because we had on one side 3 to the x plus 1. On the other side, we had 6 to the x. Are they the same number? Yes. So we know that we're right. And so the last one that's here, yeah, I'm making a recording of all this. So the last one that's here, I'm going to use natural logs again. It really makes no difference, log or natural log, except natural log is only 2 letters and log is 3 letters. So natural log is a little bit more efficient because you have 1 less letter to write. So again, we're solving for x and exponent. Most people would start by taking the log of both sides. So I'm not even going to change my language. I'm saying I'm taking the log of both sides, even though I'm taking the natural log this time instead of the log. On the left, this exponent is to the whole thing, so that exponent can come out in front. However, on the right, the x plus 3 is just to the 2. So you would have to first expand by adding, and then you could bring this x plus 3 out in front. So I'm going to distribute here 2x natural log of 3 plus natural log of 3 equals natural log of 4 plus, if that x plus 3 was in front, are you okay with me distributing right away? Okay. Now I'm going to put everything with x's on one side of my equation. And on the other side of my equation, I'm going to put everything that was just a number. I can now factor out an x. And when you factor an x out of 2x log, natural log of 3, you are left with just 2 natural log of 3. Count how many letters I've saved already by using natural log compared to log. It's quite a few. And here's our final answer. And we can type this into our calculator. Maybe we will scroll so we can actually see the whole thing. So I'll use my fraction button. Natural log of 4 plus 3 natural log of 2 minus natural log of 3 over 2 natural log of 3 minus natural log of 2. Enter. 1.573. 574. Let's check if we got that one right. I'm going to store it as x. On the right-hand side, I started with 3 to the power 2x plus 1. On the right-hand side, I had 4 times 2 to the power x plus 3. Whew. They're the same, so we know we've got it right. Okay, your questions for practice are up there, 7, 8, 10, and 12.